Hello, everyone! Chapter 3, computational functions. These are super fun. This is Ms. Ozier.
And Miss Lahar.
And here we go. So, we're given two functions, h and g, and now we want h of g of 4. Notice how I'm saying it. h of g of 4.
Wow, that's a lot.
Yep. So it's kind of like the little, the dolls that stack on each other, like the stackers. It's like you go from the inside out. You have to know what the first one is before you can do the second one, before you can do the third one, etc. So all this means is do g of 4 first.
Ooh. So you're going to plug in 4 for g, x squared minus x. So there it goes, 16 minus 4. So I get g of 4 is 12.
Boom.
And then that g of 4 gets replaced by 12.
Right. This whole value, remember, when we write it pretty, we can just substitute 12 in for g of 4. That's what's happening here. So now it's h of 12.
Yep. So now you do h of 12. You get 12 minus 3. You get 9. So that entire expression is equivalent to 9.
Right. So those of you who have been really careful with making your answer pretty, this would not be pretty. This would be the answer that you want to go back to. Okay. You guys have done this in geometry. We transformed, or we composed transformations. We did a dilation on top of a translation, et cetera, et cetera, et cetera. You've done this before.
Oh. So number 1 is the first way you can look at like how they set it up in parentheses. And then number 2, they actually use a symbol, which is just a combination. You know, a h of -3 of g.
That's the one that you guys are used to seeing in geometry. And we always said do the one on the right first. So there it is.
So you plug in h of -3, so it pops out a -6.
Boom.
So then you're doing g of -6. Be careful with your parentheses. Do all the math very slowly. And then substitute it in. 108 minus 24 equals 84.
It's that easy, people. I can click in. There we go. Okay, next one. Ooh, here's where it gets tricky.
Yep. We're going to, instead of plugging in numbers, we're actually plugging in other expressions.
Okay, so it's kind of like the substitution method of systems of equations, if you remember that from way back when. But we're essentially going to evaluate g by substituting this quantity in for x. So f of x,
we're doing f of x plus 3. So f of x is x plus 5. So you're shoving in x plus 3 to that x value.
So becomes x plus 3
and
plus
then
5.
You simplify, so we get x plus 8, and then that's what you're shoving into g.
This x plus 8.
Yep.
Distribute your thing, blah, 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 blah.
You distribute, you simplify, and there it is. So it's a little bit different. You're not really going to get, an answer, a solution.
Right, it's not a number. It's
you're going to get another expression.
Yep.
Okay?
So we're going to try that one more time.
All right.
And we picked this one purposefully, just saying.
Yep. All right. So we're going to take g and we're going to plug in x minus 1 to the x. So that's 3 times x minus 1 minus 5. Okay. We're going to distribute. I don't know what those. I don't think. My red things keep popping in.
Now, we're going to substitute 3x minus 8, that quantity, in for x in the function f. So that's going to look like 3x minus 8 squared minus 5 times the quantity 3x minus 8. Please remember, this is not, you can't be like, oh, I'm just going to square both parts. No, 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 no. This means
you double distribute. You write it twice, okay? And then you outside, inside, last. First, outside, double distribute, whatever. A lot of words we've chosen to use for this.
Okay. Boom.
So now that goes back into the expression. Simplified it, brought it back over.
Right, this was all pretty. So that's here, 9x squared minus plus 64. And now this -5 is being distributed because you have a monomial technically times this binomial. So it's a -15x plus 40. That's where this part's coming from.
Okay, you write all that down, you simplify it, and then you rewrite it. Well,
and it should be rewritten. We got a lot going on in this slide, but it should be rewritten with the pretty.
Yep. Pretty answer.
Pretty answer.
And that's it.
Have a wonderful day. We'll see you guys in class.